In this video, we're going to address how we can join together multiple data sets to answer questions that require data from multiple sources. Briefly, before we begin that discussion, I just wanted to point out that there is a section on sorting data frames here. It's pretty self-explanatory. If we want to sort our data frame based on the values of a particular series or collection of series, we can simply call the sort values method. So here we see the rows sorted based on their star values in ascending order. And we can also sort based on an index. So if we set the index to be business ID and then sort the data frame by that index, we end up with the alphabetically first indices displayed first. If you're curious about sorting pandas, objects, you can of course always search for more information in the documentation. So let's talk about joining datasets together. So often we'll want to combine multiple data from multiple sources into a single data structure to answer complex questions. For example, if we operate a business like a restaurant that deals a lot with customers coming in from the street, we may be interested in not only analyzing our sales data, but our sales data in conjunction with weather data, because of course less people are outside when it is raining or snowing or very hot or very cold. Another example is if we are, for instance, operating, if we are stockbrokers and we are interested in looking at stock data, stock prices and volumes, in conjunction with data from the news or from social media. We might have a pipeline that generates statistics about when companies are mentioned in news articles or on social media and whether those were positive or negative mentions. And we might want to join in data from this other source with wherever our stock data is coming from. In our example, we're going to join census data from the US Census Bureau to the business data that we have from Yelp. So here we have census data showing the population in various locations from year to year in the United States. So we have some towns in Connecticut labeled with various identifiers. So we've just can take this display label from the location data and parse that out by splitting it up on these commas to extract the city and the state. Now this isn't perfect. For instance, Bethel town should probably just be called Bethel, or Danbury town should just be called Danbury, but we'll take care of that in a moment. First of all, we can see that we successfully got the states out by printing the unique states in this census data. And I've prepared here a list of state abbreviations that we can use to translate these state names into the abbreviations. Since our Yelp data, the states are listed by 2 or 3-letter abbreviation. So we'll just replace the states in the census data from full names to abbreviations using this replace method. which can take a dictionary and use it to transform by simple lookup in the dictionary the values in a series to the values in the dictionary. So here now the census state data, or states, are these two-letter abbreviations. And then we're just going to remove the last word from the city names to solve this problem of ending with town, township, borough, village, etc. So we now have in our census data these new city and state columns that look similar to what we would expect to see in our Yelp data. So we've done some data transformations on this display label column to construct new columns that we're going to use to merge together the census data with the Yelp business data. And most of the time that we are joining together two data sets in pandas, we're going to accomplish that with this merge method. The merge method can be called from a data frame, and the first argument will be the data frame that we are joining to the data frame that called the merge method. And then we also want to specify which fields we want to join on, meaning when we compare this data frame to this data frame, how are we going to match up the rows of one with the other? In this case, we're going to look for where the state and city of Yelp DF matches the state and city in the census data frame. So rows from the census data frame will be concatenated onto the rows of the Yelp DF where we find matches for state and city. So we can see, for instance, here, Middleton, Wisconsin, we pulled in all the rows from the census data as well. So now we have all these population counts from 2010 to 2016 for Middleton, Wisconsin. So there's a brief description here. The merge function looks through the state and city columns of both Yelp DF and census and matches up where the rows share values. Now, this raises the question, it's obvious what happens when we find a match. Then we just concatenate the rows together. But if we don't find a match for city and state, what happens? This depends on what kind of join we are performing. There are 4 kinds of join that we will discuss. First, we'll talk about the inner join. An inner join only keeps data if the state and city exists in both data frames. So if there is a state and city in the Yelp data frame that has no match in the census data frame, then it will be dropped from the result. That means the output will be smaller than the Yelp data frame. It can't be bigger than the Yelp data frame. It can only be smaller. And in fact, it will be smaller. It will be no larger than the larger of the 2 data frames. An outer join does the opposite. We keep everything whether there's a match or not. When there is no match, the missing components, for example, if there is a city in the state in the Yelp data frame that is not in the census data frame, all the columns associated with the census data frame become null values, but we keep the row from the Yelp data frame. Likewise, if there are cities and states in the census data that are not in the Yelp data, all in the result, we would have a row where all the Yelp data is missing. It's all none. But we keep the census data for that row. So that's inner and outer. There's also left and right, where we prioritize either the left data frame or the right data frame. In a left join, if a city and state exists in the table on the left, but not on the right, then the values for the table on the right are set to be null. But we keep all entries from the data frame on the left. That means the result will be the same size as the table on the left. If we have a right join, the opposite is true. We keep everything from the census table, so all cities and states in the census table, those rows are all preserved in the output. But where there's no match from the Yelp data frame, the Yelp data will be set to none. If in a right join, if any cities and states are in the Yelp data frame but not the census, those rows are dropped. There's descriptions of each of these joins for you to review, as getting these terms straight can take a little bit of practice and repeated exposure. Can also be helpful to consider a graphical representation. So joins, many people are familiar with them from SQL rather than from pandas. And here's a little visual representation of the different types of join. An inner join, we only keep the rows which are present in both tables A and B. A left join, we keep all the rows in table A, and anytime that there's missing data, meaning there's no match from table B for table A, we fill in null values. But any rows in table B that don't overlap with table A are simply dropped. So the unique rows of table B are dropped. A right join is the opposite of left join. And then there's also outer joins. This is the typical meaning of outer join, where we keep everything regardless of if there is a match or not. As I mentioned, since so by default, pandas performs an inner join. We can specify what kind of join we want by using the kind keyword. Or it's not kind, it's how. Sorry, it's the how keyword. There we go. So we can change between left, right, inner, outer, etc. But by default, merge uses an inner join. And we notice that the merged data frame is much smaller than the Yelp data frame, because there were many cities and states in the Yelp data frame that were where we couldn't find a match in the census data frame, and those rows got dropped from the result. So merged, this joined data frame has much fewer rows than the original. So we know there's a lot of cities in the Yelp data frame that aren't in the census data frame. If we want to keep everything from the Yelp data frame, we should perform a left join. We should keep everything from the table on the left. And then we see that the output actually, for the merged, has more rows than the original. And this is because there must be some places where we're getting multiple matches from census on the Yelp data frame. So that's another important thing to be aware of and to watch out for, is if you have multiple matches For instance, say Middletown, Wisconsin repeats in the census data several times, we're going to get a new row in the output for each match. So we might duplicate some of the Yelp data several times corresponding with these different matches. And that's something to watch out for if you're working on the DW Mini project. That could happen if you're not careful. So this discusses joining together tables with different columns. But sometimes we have two data sets where they have the exact same columns, but they refer to data collected at different times or in different places. In other words, the tables look the same but contain different data. One example near to my experience is the New York City subway system releases data concerning the customers passing through the system. So there are counts that they make available of how many people are coming through the turnstiles every day. So they have counts like entries and exits here, and if we zoom way in, we can see something like during the 4-hour block between 3 and 7 a.m. Oh, this is taking a long time to load. The counts went from 6,930,882 for entries up to 901. So 19 people between 3 and 7 a.m. at this particular turnstile, 13 people entered. And they release this on a weekly basis. So if we want to get all of the subway data for an entire year, say, into a single data frame, we also need to perform a type of join. But this kind of a join is not what we typically call a join. We would just call it concatenation. So I'm also going to show you how to concatenate together tables. So here is our data from November, the week of November 18th in 2017, and then the week of November 11th in 2017. And if we want to just concatenate these together, there is a pandas concat method where we can give a list of data frames that we would like to just stack on top of each other. And once we do that, we see the result for November has unique dates that range from November 5th, 2017 through November 17th, 2017. So we have 2 weeks there in the result. We can also use concat to perform inner and outer joins based on indices. So for example, if I have counts on how many businesses there are in each city, incidentally, this is better done just by saying Yelp DF city value counts. There we go. If I want to join this result onto the original data frame, I could accomplish that with a concatenation, where I will take the original data frame, set its index to be city, and concatenate this city counts to the data frame with the index changed to city. And since I'm concatenating on a column rather than rows, I'll specify that this concatenation is along in axis 1. And finally, after I accomplish this join, I'll reset the index. So now each row also has a city counts that shows the number of businesses in that particular city. So in Middletown, Wisconsin, where's our city column? I see state. Oh, right. City was the index, so when it got reset, it got named index. Okay, so here's the city. So in DeForest, Wisconsin, actually, there are 6 businesses, and in each row for businesses in DeForest, we see that 6. People often want to join aggregations onto the table where they have aggregated the data from. This is not very efficient, and I would recommend not doing it unless very necessary. Usually it's not necessary, but when starting out, it's sometimes confusing or unclear how to accomplish, for instance, filtering using a aggregation on an original data frame. So for instance, if we wanted to filter the Yelp data frame for cities with more than 10 businesses, your first thought might be to do something like this, to concatenate on the city counts column. Instead, what my recommendation would be to select out the cities with more than 10 businesses from this city counts series, and then check if the city in the Yelp data frame is in that selection. But that's getting a little off topic from what this video is about. And at this point, I'm going to conclude. In the next video, we'll wrap up by talking about working with time series data, as well as we will briefly show a little bit on visualizing data within pandas.